Hello! Ag Easy works with agricultural customers to help you save energy. The program, offered through the Public Purpose Programs or PPP charge on your utility bills, provides your business with energy audits, technical assistance, web-based energy monitoring, and more. Contact our team to learn how to take advantage of these benefits. In this video, you'll learn about pumping systems and how to identify energy-saving opportunities to operate them efficiently. This video focuses specifically on well pumps, booster pumps, and variable frequency drives. First, let's talk about the common components of a pumping system. To establish some common language, you may have a well pump with the motor either submerged at the bottom of the well or with the motor mounted on the surface and a shaft going down the well to the pump. The pump is made up of an impeller or impellers if it's multi-stage, and a casing, sometimes called the bowl. At the discharge of the well at the surface, most wells have a valve that can be used to control the flow, and you may or may not have some kind of storage or reservoir, and you may or may not have a booster pump or booster pumps. Let's go through these components one at a time and talk through the ways to save energy at each of them. Then we'll talk about system design efficiency as a whole. First, let's talk about pumps. Every pump is designed for a certain flow and pressure, sometimes called feet of head, and is rated for a certain hydraulic efficiency. If the pressure changes in the system due to a valve being choked off or the water table dropping, the flow changes and so does the hydraulic efficiency. These operating points at various pressures and flows form a curve called a pump curve. Every pump has a specific curve. The power required by a pump depends on the pressure, the flow, and the hydraulic efficiency. So, broadly speaking, ways to improve the efficiency of a pump are to reduce the flow, lower the discharge pressure, or increase the hydraulic efficiency. Flow can sometimes be reduced by optimizing the amount of water applied through soil moisture sensors. For example, pressure can sometimes be reduced by properly sizing distribution lines, selecting sprinklers that require lower pressure to operate, or reducing the number of choke points in the system, such as partially closed valves. And finally, the hydraulic efficiency can be improved by, first of all, purchasing pumps with the highest available efficiency and by testing existing pumps for wear and tear by getting a pump test and overhauling or replacing impellers and bowls as necessary. Selecting a high-efficiency pump motor is another way to save. Taken all together, this is sometimes called the overall pump efficiency, or OPE. If your OPE is above 70%, that's usually a good sign. Sometimes pumps can get worn out from sand or other items and can still produce enough pressure. So it may have an OPE below 50%, which means more than half of the electricity you're paying for is essentially just heating your water rather than moving it where you want it. Let's talk about valves and variable frequency drives, or VFDs, sometimes called variable speed drives. From an energy perspective, a valve is just a way to dissipate useful energy. When the valve is closed, the flow and pressure downstream of it may drop, but the pressure on the other side increases, which is what your pump is pushing against. A more efficient way to control flow is by installing a VFD, opening the valves, and using the VFD to slow down the pump motor. When a pump operates at a slower speed, the whole pump curve shrinks, meaning the pump does not produce as much flow or pressure, and the power requirement to operate a pump can often drop substantially, since pressure varies exponentially with a change in flow. Another way to save with a VFD is in situations where you have pumping zones with different elevations, or are pumping water to a higher elevation and allowing it to drain down to a lower elevation. With a VFD, you can operate at just the minimum required pressure for each zone. Reducing the pressure 10 to 20% typically reduces the power by about 10 to 20% as well. Here are the key takeaways for saving energy with pumps and VFDs when it comes to designing systems efficiently. It starts with designing your distribution system as efficiently as possible, with sprinklers that require the least amount of pressure to operate, sizing your distribution lines plenty large for smooth flow, dialing in the amount of water each plant or zone needs, installing a VFD for exact flow control, and then selecting a pump with the best hydraulic efficiency and the most efficient pump motor. For more information about potential incentives, or to schedule a free energy audit with the AgEasy team, contact us today or visit our website ag-easy.com.